Right now, Sanath Raj, the leading researcher and domain data scientist in telecom from India. He's going to talk about generative AI that can deliver up to trillions of dollars to the world economy. Sanath Raj, please, a very warm welcome. The leading engineer and domain data scientist in telecom, Sanath Raj. LangChain for generative AI.
Hello, hi everyone, good evening, thanks for being here. So what we will do today is understand one of the most popular frameworks that helps us to build products really quick, LangChain, and there are competition or products similar to this. We'll probably touch upon that a bit. So today, real quick, we are going to understand why there is a need for a framework like this. What is a LangChain? Why are we interested to know that? And few basic aspects about what LangChain brings in. Like it helps you brings the tools, routers, agents, racks, and even build chatbots for yourself. So LLMs or the foundational model, as we know it, are good at a lot of things. It can do language comprehension. It can do or be very good with reasoning. It could summarize. It could build code as a copilot. But that's with the foundational model. But also, there are certain specific aspects where it has to get better, or the contextual or the data awareness is missing. That could be like a cutoff date of a training date. If a model is built probably on data till 2023 December, it may not have something as recent as yesterday or last month, or something specific knowledge that's within the company or within a particular team that's probably not known at the time of the training. And sometimes it could hallucinate, and we could not have things that are factually correct sometimes. So that's an issue. Bias and ethical, I think over a period of 1-2 days, we have looked at how bias and ethical issues become more and more critical when we take on this Gen AI journey. And like I said, there's a lot of dependency on training data, and it's not really good at understanding things that are pretty complex. So when things are standing at this juncture, how do we make use of certain things that could augment the foundational model to make it more context and data aware? That's something that we will look at. So this talk, we are going to understand one such library or one such tool that is useful, which is LangChain. It's an open source tool. It helps the developers to build things real fast. But what's LangChain? It's like the name suggests, it's a chain that binds various components or modules around the language model, and it enables developers to build or have capabilities done real fast. And why is it getting popular? One, it's like a go-to framework by more developers. It makes things easy and fast with the integration. It simplifies the overall journey of getting the foundational model up and running with the user-specific tasks. And it helps us. LangChain can help us with many of things. Like building, we have LangChain, and if you want to have things productionized, we have LangSmith. And if you want to actually deploy it and serve it as an API, then you have also a component about it. So we have LangGraph that can actually build agent and agentic workflows. LangServe that could actually deploy and make it as a RESTful API. And if you want to evaluate, monitor, then we have LangSmith. And overall, from a landscape perspective, you have LangChain, and then you have community integrations with the Azure and with the OpenAI. But what problem are we trying to solve? So, like I said, LLMs have a capability to do a lot of things, but there are certain things where it has to get good at. And one thing that certainly is required with regard to problem statement or solving is making the foundational model or LLM more context or more data aware. So with regard to making the LLM more context or more data aware, there are some of ways or some of means of getting it. So one of the easiest or one of the most popular one is the prompting thing, where you define the system behavior to the model and you tell how the model should behave. and prompting would precisely do or give you results as expected. So that's like the easiest of the lot. The next one is making it more contextual by using technique like RAG. That's another thing. Or you could go one step ahead. These are like incremental. You could do PEFT or fine tuning, where you could actually have some training data and enhance the model with the more data. That's on PEFT. But there's another option of having something from the scratch and do a full training yourself. But on these verticals, what we are seeing, prompt and RAG is where LangChain is really good, and it can be useful. So probably we'll look at cases and scenarios where we could use for the verticals in blue and green. So we understood LangChain as a model that changed multiple aspects around the model. One such thing is the tool. And tool is something that helps us to interface the LLM with some of the APIs that will solve the problem of probably not having factual data or not having up-to-date data. For example, if you want to have it integrated with the LLMs, that's one of the tool. But also we could have it integrated with the Wikipedia. We could have it integrated with DuckDuckGo, Google Search, etc., which gives you information that's very factual. Connect that with the databases, etc. So that's the tool part. So we'll look at very easy or simple examples of how the code snippets will tell us to use the tool. So if you look at, there are two examples here that I have. One is for the specific tool called DuckDuckGo, which is equivalent of a Google or any search. The other one is Wikipedia query. And I instantiate the model saying, here search is equal to DuckDuckGo search. And then I ask model.invoke and ask my specific query, I get the response. So this answer, what I see is not coming from the foundational training model. It's actually coming from the integration of, say, DuckDuckGo. Similarly, if you want an information from Wikipedia, you could also get it similarly. Say model is equal to Wikipedia wrapper or any other object, and do a model.invoke and call your query. And the answers are coming, like I said, it's not coming from the LLM foundational model, but it's coming from the API. So this way, you're actually solving the data accuracy or relevancy, or having more up-to-date information. And the second things, other than tool, one good aspect about LangChain is called as agent. So here, with regard to agent, we have something called as React agent, which has the capability to understand based on reasoning, and it has the ability to reason and act. It's a bit of autonomous that way. And it actually automatically chooses the right tool or right path based on what's there. And it's also a good way of integrating with multiple type of say modality, etc. So with regard to the React agents, let's look at a very simple implementation. So here we basically have all the imports, instantiate the LLM, and then we have the template or the prompt template that defines the system behavior. And here I'm saying answer the following questions as best as you can. So you are prompting the foundational model to behave in a way how it wants, and then you basically have in this example there are three categories or three aspects in which you want the machine to react or machine to give you the answer. So one is the tool which I'm engaging is a REPL tool, which is a good tool if you want to solve some Python related problem. So it's like a colleague or friend who knows very good coding. So this is that person. The other person is the Wikipedia wrapper who has more factual or more contextual information. And the other one is the Google search or the DuckDuckGo search. So with the definition of what each tool has to also say when is Python REPL useful. Useful when you need a Python or equivalent like a code specific problem. Wikipedia is useful when you look up a topic, country or a person, then Wikipedia is more relevant. And I'm also saying the behavior is useful when you need to perform internet search that the other two tools cannot provide, then you use this tool. And what I'm doing is at the end, I'm actually creating an object called tool, and I'm creating a list that has all the three tools together, like Python, REPL, and Wikipedia, and DuckDuckGo. And now I'll actually go and invoke this React agent, which is more like a chain. So I create a React agent where I plug in my LLM and also the prompt, which is the system behavior. And I create an agent executor which has the agent, the tools, which is collection of all the various tools, and put that as one block. And then now I invoke the model within the agent. And I have different types of questions. So I ask a question about a sports personality here, who is Sachin Tendulkar, who is a cricketer, and I ask a question about a Python-specific question. So the question here I am asking is, tell me about Sachin Tendulkar, who is a very famous cricketer. And here, because the question is more about personalities and correct informations, so it is saying entering the executor chain, and it is actually, because it is react, right, reason and act, it actually says I should use Wikipedia to look at this information, and it actually gives the information from Wikipedia. So next time around, when I actually use the same set of code, and instead of the question which is more factual or more current affairs, I now ask a question which is a little more technical. Now I say, write a user-defined function that can calculate the RMS value for a regression function, so which is a very specific task. And then I use the same or invoke the same agent. This time around, it's not actually invoking Wikipedia, but then it understands this is more Pythonic, so it says I'll use REPL tool to write the function and calculate the RMS value. And if you see the verbose part, it actually looks into the input and takes the difference between the predicted and the actual value, and then the RMS is calculated. And if you actually look at the output, you actually get the code for the RMSE. So what React does is, it actually has the capability to reason and act. It's quite autonomous, and it could actually be solved to solve different use cases, different LLMs, different agents based on what's required. So something on the similar line, but not as autonomous as React agents, are router chain, which provides capability to the foundational model now to route based on the scenario. It's like you have different kinds of people, or one person wearing different kinds of hats. So it could be a Python programmer, it could be a Wikipedia expert, it could be a legal expert, or it could be a multimodal model like image generating, text generating, video generating. Based on the scenario, it now gets routed like a decision tree, and each of the trees that get executed. So here in this example, we'll see how do we actually create this router chain. And we start with the setting the system behavior. We are saying you are an expert, so either in physics, or here we are having a scenario where one is a beginner physics teacher, the other one is the expert physics teacher. Based on the question, the model or the chain has to be smart enough to route it to different scenarios. So here the beginner template expects, or rather answers, the questions that are a very basic level, and the expert would actually answer the question probably at a PhD level, at a more a detailed level. But it has to understand it by looking at the question. So now if you look at these specific questions, which we are going to plug in later, where I have two kinds of questions. One is like, how do magnets work, which is a fairly simple question, and the second one is how do a Feynman diagram works. So the other one is a fairly advanced question. So based on what's asked, it actually, for how do magnets work, it actually engages a beginner chain, and then it answers saying that the magnets work based on magnetic field, etc. But here in this example, it's actually engaging a beginner thing. But then for the same chain, you invoke, but with a different query. This time around, you ask how do a very detailed concept, or how do an abstract concept about physics to be explained. Then it understands. It's because of the prompting. You have set the system behavior. So now the system is smart enough to say that you have to engage a different chain, or a different agent, or a different router, or a different person, and it actually works that way. But in this whole idea of being router chain executed, we could have things a bit more in our control by making or having some business rule implemented, by having some sort of semantic similarity of some sort of if-else condition. That's something we will look at now. So in this example, it's same as physics or maths. So here it's slightly different. It's a mathematical professor, and the other one is the physics professor here. And based on the questions you are asking, whether it's physics or maths, it should actually invoke the right kind of model or invoke the right kind of response. But here what we are doing before actually invoking, we use the semantic similarity. So whenever we want to use the semantic similarity, we'll have to convert the words to embeddings. You actually convert words to numbers using embeddings, any embedding model. So now you have a list, or you have a tuple with the numbers, so that's your system behavior for both physics and maths. And you have this system behavior also embedded. Then the user comes in, asks a question. So asks a question here about what's a black hole, and the second question is what's a chain rule in differentiation. So one question is more physics related, the other one is more mathematical. But what we are doing here is actually we are actually converting the query also to embedding. So I have my system behavior or the expectation embedded already, and my query is also now embedded. So now I can actually run a cosine similarity to see whether the question asked is similar to my behavior 1, behavior 2, or behavior n. And accordingly, I have an argmax argument which picks or invokes that object or invokes that model and accordingly engages. So if you look at the example here, what's a black hole, it says using physics, because the cosine similarity of the question of what's a black hole is more similar to the system expectation of a physics template. And second time around when I ask what's the chain rule of differentiation, it understands it's a mathematical question, and then it invokes the mathematical agent. So this is how in the context of use case, when you have multi-modal, multi-agent or multi-systems being involved, you could use routers or a React agent to actually solve your problem. The other useful example with the LangChain is doing something like RAG, where you have a retrieval, augment, and generation. So in the first part of the code, what we see here is actually you have the documents. This is the input data, which is not part of your training data. This is something that you give because that will give you more contextual or more specific information about your organization or the use case. You chunk the document, you make that into pieces, convert all of that into numbers, which is the embeddings. And then once the question comes, you have the contextual data which you passed as the chunks also in the numbers, and the query that you're asking also is now converted to embeddings. And then you look at the, again you do a semantic search of nearness of what is the question that you've asked is near to which of the chunks that are there. And what you do is basically make it more contextually richer by feeding this additional context with the question. So I can have very specific questions. Let's assume we are talking about building an app that will help users to understand details about the insurance policy, etc., which is very specific to a use case or a project. So I could load all the PDFs or all the Word documents or all the information about this particular knowledge. And now the question is specific to this insurance policy or this insurance scheme, which is not part of my foundational training data. But then because of a tool like LangChain, I could actually make it more contextually aware. So let's look at how do we do it with the code. So now I have a function, utility function, which is a loader function, which can read any of the document, PDF, Word, or text, etc. And once I have the data loaded from the document loader, I basically have a chunking method that instead of passing one entire document at once, I actually split it into, say, 100 words, 1,000 words, whatever, and then pass it to, or save it as chunks. Once I save it as chunks, I now bring in vector database, wherein this vector database can actually save the embedded information of the chunks and store it as numerical vectors. And now the information about the context and about the query will be used in the next stage. But whenever it is retrieved, it has to be retrieved based on the contextual similarity or semantic similarity. So that's what we are doing here. Once we have the embeddings, we actually save it in a vector database, and we store that as part of the vector store. And then now I have my setup ready. So now the user is coming to this application and trying to ask questions that are very specific. So in this example, what I've done is I've actually passed a PDF, which is about a very popular document, which is about attention is all you need, which is about the BERT and the transformer. So I've loaded that document in my document loader. I've chunked it, and I've passed it to the vector database stored as embedding. So now, when a question that's asked now, what is an attention layer? What we do is we actually ask the chain or the LLM the question, and also we look at this information in the information which is already there in the vector store. So we use the cosine similarity or nearness measure to understand which of the chunks, say 100, 500, or 1 million chunks, which of them which is already there in the vector database. This question of what is an attention layer, or how does this insurance policy work after say 18 years of beneficiary, etc., whatever is the specific question, we look at the chunks that are very near to this in terms of the question asked, and we retrieve top 3, top 5, or top 10 based on this. So now the idea is basically you have this information. So the idea is, if you understand a question better with the additional context, LLM also would understand the question better with the same context. So that's the entire idea. So now you actually pass this additional information with the context, and now you ask the question, what is attention layer? Even if it is not part of the foundational training model, because you have contextually you have made the LLM or the model more richer, it is now capable of answering the questions which was not part of the foundational model. So that's how RAG works, and RAG is one of the super useful tools when it comes to doing implementations on GenAI or LLM. So that's on RAG. And if you want to use LLM to build a very specific custom chatbot, let's see how do we do it. So here in this example, I'm using a Hugging Face model, and I'm creating an LLM class. I'm downloading the model from Hugging Face, or I'm calling any OpenAI model. Then what I do is there's a class of LLM, and then I do an invoke. I can ask any queries, or I could actually build RAG on the model, or I could have any prompt template or routing or agentic behavior expected. So here I'm setting the system expectation by using a prompt template saying you are a very helpful assistant. That means you are the foundational model would work very differently from a ChatGPT, because you have to understand ChatGPT or models like that are designed or tuned to actually have a conversational part, but foundational model may or may not be very good at it. So you're actually setting the system expectation by giving such sort of information, saying you're a helpful assistant, you're good at problem solving, whatever. And then you have your chain built with the prompt with the LLM, and then you have user asking the question, where user can input the question and the LLM can actually answer. So here I'm asking a very specific question to the LLM, now being augmented or made into a chat conversational bot, and ask the question, what is a rocket? And it answers a rocket is a vehicle, etc., because it was part of the training data. But now I ask the question of who invented it, where I expect the chatbot to have the context of what is it. Here I'm referring to it as the rocket, because that's part of my conversational history or memory, but it doesn't understand. So I said it will have the problem of being factually correct. So now it actually hallucinates and thinks I'm talking about something, and it says invention of wheel. Who invented it is invention of wheel is attributed to some century ago. But this is one limitation that we have. So how do you overcome that in LangChain is basically having the same set of code, but having one additional attribute in the chain, which is not only the LLM and the prompt, but also you have the memory block, which is nothing but have the conversational buffer memory stored, and you could save that as a JSON or have it saved in your S3 in AWS. But that's the memory which is part of the current cache or the conversation, and then you stack that together as a chain which has LLM, prompt, and the memory. And now if you ask the same similar question to the chatbot, it works really well. So I ask what's a nebula, so it says it's a giant star, etc. But now if I ask the question, how is it formed, so it understands my question is about the nebula, and it has this conversational awareness because this conversational buffer memory that's getting stored. So yeah, so these are the things I thought I could share with you with regard to LangChain. So Thank you, everyone, for being a very patient audience. Thank you.
Thank you very much for your performance. Thank you, dear Sanat Raj. And we have a few questions from the audience, and if you don't mind, I will ask them. At least one.
Sure.
What potential issues or challenges might arise when using LangChain to optimize a language model, and how can these be addressed?
If you can repeat the question, what potential issues?
What potential issues or challenges might arise when using LangChain to optimize a language model?
Sure. Okay. So the question is, what issues would one face while using LangChain for productionizing? So the issues, what I've seen is LangChain works, real good, and it's helping us to solve the problem real quick. But one of the issues could be, when we want to actually get output in a specific format. Let's assume I've defined the system behavior to only give me JSON output. Sometimes it may or may not, follow. Then if the schema is not the same, then we have an issue in actually, getting the data of a different data quality than expected. So the production pipeline may fail. This is one. The second thing is when it comes to frameworks like RAG, when it comes to retrieval, only as retrieval as a thing, if you could compare this with its competitor, probably Llama Index, sometimes the other one works better, but I'll not say that's always the case. But there are issues with scaling and productionizing. That's something that I've faced. Yeah, sure.
Thank you very much. Thank you for answering the question. Sanat Raj, applause to the speaker.